Hey, good morning, everybody. This is Mr. Aynesworth here at Great Oak High School. We're going to get into a new lesson here, lesson 1.3 in AP Pre-Calculus here in the year 2023. And we're going to be talking about quite a few different concepts. We're going to be talking about the rate of change and the instantaneous rate of change. We're going to be talking about and determining how to determine concavity using what's called inflection points. So we're going to do this in the context of a business problem. All right. And before we do that, though, I want to talk about some those concepts, or a few particular concepts you're going to be needing to know throughout the lesson. So I'm going to sidetrack for a moment, do a little prep here. So I'm going to go to a little example that I came up with here and talk about a few concepts that you kind of need to know when you're going through this problem. First of all, let's talk about a tangent line versus a secant line. Okay, so this goes back to geometry here, and so look at these two circles I have on the lower right of the screen here. And the first circle here, if you take a look at it, this is being intersected by a line, and this line intersects the circle twice. Well, this line has a name, and from geometry you probably remember this. It's called a secant line, and any line that intersects a circle or even a curve, okay, in this case the curve is a circle, but it could be anything. If a line intersects the curve twice, okay, or at two specific points, you call it a secant line. Now the other type of line that we want to talk about today is called a tangent line, and if you look at the difference here, in the second diagram here, I'm talking about the one in the smaller circle here. Notice that it only intersects the circle at one point. So no matter where I drag the circle or the point around the circle, it intersects at only one point. And as you guys probably remember from geometry, it's perpendicular to the radius, and it only intersects the circle once, okay, as opposed to a secant line. A secant line intersects the circle at some 2 points. Okay, I don't care where it intersects the circle, but if it intersects a circle or a curve twice, we call it the secant line. So having known that here, let's talk about the tangent line, because the tangent line is actually very important in mathematics. And so look at the top of the screen here. The main idea that we're going to be using in this case to determine the slope of a curve, okay, and the curves could be, they can be in many different shapes. So this is just one example that you're seeing on the screen here. It's a fourth degree polynomial function, okay, and the slope of the curve, or what's called the instantaneous rate of change, okay, at any point on the curve is equal to the slope of the tangent line at that point. Okay, this is a very, very important concept in mathematics. And so what we're going to do here, I'm going to animate a point on the curve P. So look at P right here. And I'm going to slide X, so I'm going to go from left to right and show you how the slope of the curve, which is approximated by the tangent line, which is in black up here, changes as you move along the curve. So notice that get your eyes on P now. So there's a black line which represents your tangent line, which intersects the curve at only one point, like I was talking about earlier. Notice it has negative slope. It's going down to the lower right. And so as x increases here, as you move along the curve here, the function is decreasing because it's going down. The slope's negative, which means the function's decreasing at that point. Okay, but notice that as you get closer and closer to the relative minimum, I'm talking about that point at the bottom there, all right, the slope of the line is still negative, but approaches zero, because at the bottom, at the relative min, okay, you have a tangent line which is horizontal, and as we know, horizontal lines have zero slope. All right, they're flat, they're horizontal. All right, so if you start off right here, if you go along the curve here, it's decreasing, it hits that minimum point where the slope is zero, and then of course it starts to increase. So notice now we have a positive slope of the tangent line. So the function's increasing through here. It's getting steeper and steeper and steeper until you hit what's called an inflection point, where it changes concavity. That's technically what it means, okay? And then it slowly decreases. It's still increasing, but at a decreasing rate. So it's still positive, positive, positive until you hit the maximum at the very top of the hill there. It's called a relative max, where the slope is zero again. And then it changes the decreasing here until you hit that inflection point, where you have the steepest negative slope and where the rate of change is actually the fastest, okay, at the inflection point, and then it levels out again. So it gets the steepest at the where the most negative is in this case, at the inflection point, and then when you hit that relative min again at the bottom, you get the slope is 0, it's flat, and then it gradually increases and increases, and from left to right. Okay, so the question is like when is the rate of change the fastest? Okay, so let's go through that again. So let's slide it from left to right. Okay, so notice that the slope is negative here. All right, negative, and at the bottom it's 0. So it's bottom at 0 there, and then it's increasing. It's getting steeper, and when it hits the inflection point, it's the steepest, which means it has the fastest rate of change. So remember that. At the inflection point, it has the fastest rate of change. Whatever we're talking about in the business problem, it's going to change the fastest at that point. So you want to find that inflection point. And then it starts gradually slowing down because you're approaching 0 here, meaning it's you got a flat or a horizontal line right there at the max. And then it decreases again, so it starts speeding up, but in a decreasing fashion. And then until you hit that inflection point where it decreases the fastest, and then it levels off again till you hit the relative minimum, and then it speeds up again. Okay. Now let's talk about concavity for a second. The way you tell if it's concave up or down is by looking at the rate of change. So now the slope, which is the rate of change, right now it's some negative number because it's got negative slope here at P. It's going to the lower right. Okay, it's a decreasing function at this point. So it's negative. I don't know what negative slope it is, but it's steep. It's like maybe -9 or something like that. It's really steep. Down 9, right 1. And then I'm just making that up because I just give you a number here. So it's negative, and then as you move along the curve here, it's starting to flatten out. So, but it's still negative, and it's approaching 0. So if you think about it on a number line here, if all these slopes are negative, all right, and you're approaching 0, the rate of change is actually increasing. Okay, because you're approaching 0, so you're going to the right on the number line if you think of it that way. And then right here, obviously the slope of the tangent line now is positive, and it's getting steeper and steeper. So the slope of the tangent line, or the rate of change of the function at that point, is increasing over that interval. So let me go back through that again. So when the slope of the tangent line, or the rate of change, is increasing over an interval, it's got to be concave up. Okay, it kind of looks like a valley as opposed to a hill. Okay, so concave up, think valley. Concave down, think more like a hill. All right, so when a function or the rate of change is increasing over an interval, it's got to be concave up. And then when it hits the inflection point, it changes concavity. So now the rate of change is the fastest at the inflection point, and then it slowly decreases because it's approaching the top here where the slope of the tangent line is 0. And if it goes from some positive number here to 0, you're obviously getting smaller, so it's decreasing over that interval until you hit the inflection point. So it changes from positive to negative, and it's decreasing until it hits that inflection point where it's decreasing the fastest, and then it changes again. Okay, the concave up. That concave up means that it's got to be increasing over the interval. So after the inflection point, notice that it approaches 0 again, that flat, where the tangent line is flat, which is always at the relative minimum in this case. And then of course it just takes off upward here, so it gets increasingly fast. So when a function is increasing over an interval, when the rate of change is increasing over an interval here, it means that it's concave up, so it kind of looks like a valley as opposed to a hill. So this concept of using inflection points and looking at where it changes concavity is important. Remember, inflection points is where it changes the fastest, either in a positive sense or a negative sense, depending on the slope of the tangent line. Okay, so let's get right into our lesson here, and let's apply it to a business problem here and take a look at the mathematics within it. Okay, so let's read the problem. Over time, All economies go through regular cycles of expansion and contraction. This is called the business cycle. Okay, so today we'll look at a graph depicting the gross domestic product. Okay, it's called the GDP for short, so the gross domestic product, and how it changes in respect to time. Okay. Okay, so what do you notice about the graph? What do you wonder? Well, first of all, let's go ahead and let's analyze the graph a little bit. Okay, what's going on from A to B to C to, to F? Well, I don't know why they switched order here, but who cares? So F to D to E. So what's going on in the business cycle? So T, time in years here. I guess I don't know what the units are. So units, question mark. Okay, don't know what the units are, and I don't even know what the units are in GDP. I don't know whether it's in millions of dollars, billions of dollars. It's probably in either millions or trillions, because these numbers, in terms of the overall, the entire United States, tend to be kind of big. All right, so I don't know what the units are on either axis here. That's the answer to the wonder part. I have no idea, but I do know that it's changing. So before we answer these questions and write down some responses here, we should probably identify the inflection points and to find out where the function's increasing and decreasing. So, for example, I know that if we start here on the y-axis, where it intersects the y-axis here, I know that it's increasing in this small little interval all the way up to the maximum right here, the relative max, or we call that a peak, however you want to say it here. And then it goes back down. So I'm going to switch colors here. So it starts to decrease after the peak, all the way to the relative minimum, which is down here. This is a relative minimum. So the low points represent minimums. It's kind of like the bottom of a valley as opposed to the top of the hill. Okay, so it decreases until you hit that minimum, and then it changes. Okay, it increases again. Okay, so I'm just analyzing here. I'm just figuring out what's going on until it reaches the second peak. So peak 1 versus peak 2. Okay, or you can say max 2. I like relative max better. So max number 2. And then, of course, it decreases again. So it's increasing and then decreasing over time, which is kind of natural in the business cycle, until you hit the second relative minimum, which is down over here to the lower right. So minimum number 2. Okay, and then it increases again. So, but notice that the second relative minimum is higher than the first relative minimum. Also notice that the second max is higher than the first max. So it says, what do you notice about this graph? So it increases and decreases. That is true over time. But overall, since the maxes are getting bigger and the mins are getting bigger, things are generally going upward. There's an upward trend. Things are getting better over time. Okay, so let's write that response down. Okay, so the GDP, gross domestic product here, okay, increases and decreases over time. So increases goes up, and decreases goes down over time. That's the first thing I notice. Okay, so also, okay, since the maxes are increasing, they're getting higher, and the minimums are getting higher, there is also a general upward trend, even though it goes up and down. Okay, so I'm just going to say there is a general upward trend. Things are improving, is what I'm saying. Upward trend. Okay, what does that mean? Things are improving. Economy is improving. Okay. Okay. Now, what do we wonder? Well, I have no idea what the units are. Okay, so my question, all right, what are the units? Okay, I don't know. What are the units? Don't know what the units of time are. Are they quarters? Are they months? Is it years? In the GDP, is it dollars and millions, or trillion, or billions? I really don't know. Billions or trillions. I got that backwards. But anyways, here we go. So that's the first thing I notice here. And number 2, it says at each of the points A, B, and C determine if the GDP is increasing or decreasing. Okay, so let's talk about that. So at A, you notice that it's in the interval where the function's increasing. So let's just note that. So A is increasing at that point. All right. And then B, it's in the interval B and C is where the interval where the function or the GDP is decreasing. So B and C, okay, it's decreasing at that point. That's why it's kind of nice to analyze the graph first. All right. So analyze the graph first, go back to the questions, go back and forth, and you may answer the questions in a decent manner. Number 3, the maximum and minimum values of a business cycle are called peaks and troughs. Okay, so peaks and troughs. I call them maximum minimums, but I guess the minimum you could call it a trough. So let me write that down too. So trough 1. Okay, trough or low point, minimum. Okay, you can use, those are kind of like synonyms, right? Okay, let me see. Label them on the graph. Okay, we already did that. Check that out. We already did that, so check that off. What can you say about the rate of change in GDP at these peaks and troughs? Okay, so now let's go to this. So I'm going to go to red here. Pick a red pen. Okay, the rate of change of the GDP. So rate of change of the GDP. So rate of change, ROC is rate of change, ROC of the GDP. ROC of the GDP. Okay. All right, now, what is it? Well, all right, let's analyze it here. So let me go back to my little lesson here. Using this cool program called Geometry Sketchpad. Okay, so I'm going to go to a peak. Okay, there's the peak. Now the tangent line at the peak is horizontal. All right, and horizontal lines have a slope of 0. So whether you're at a peak or at a trough, okay, which is down here at a minimum, the tangent line is horizontal and the slope is 0. So just keep that in mind. Basic stuff. So let's draw them in. So right here at this first peak here, I'm going to draw a tangent line right there. I'm going to put down m equals 0 where m equals slope, so I don't have to keep on writing this right here. And at the other peak, the tangent line has a slope of 0. At the minimums here, or the troughs, the slope is 0 here. And over here, the slope is 0 here. Okay? So that's the first thing. So the rate of change of the GDP at both, okay, at both the peaks and the troughs is equal to 0. At both the peaks, okay, and the troughs, which are the minimums, is equal to a big 0. Okay, it's horizontal. Tangent line is horizontal. Tangent line is horizontal. Let's keep that in mind. Okay, that's number 3. Is GDP increasing or decreasing at a constant rate? Explain. Okay, so constant rate implies a linear function here. So, and the graph is definitely not linear. Okay, so I'm going to say right off the bat, I'm going to say no. Okay, the graph is not linear. You know that linear functions have a constant rate of change, and obviously that graph is not a line; it's a curve. So it's not linear. So is the GDP increasing or decreasing at a constant rate? No. So more specifically, though, if you take a look at it here, let me go back to the other program here just to exemplify. When you're close to the peaks and the troughs, like right in through here, all right, the changes of the slope is gradual. All right, it's changing. It's either increasing or decreasing, which depends on which side of the men you're at, right here. So at the peaks or the in this case it's the trough because it's a minimum right here. The GDP or the change in the rate of change in the function, whatever the function represents, changes gradually until it reaches that inflection point where it changes the fastest. Okay, so just keep that in mind when you answer questions here. So I'm going to say that near, let's say, near the troughs, okay, or the peaks and the troughs actually. So near the peaks and the troughs, all right, the GDP changes gradually. Okay, but near the inflection points, okay, remember that's the fastest rate of change, and it changes the fastest. Okay, so near the inflection points, GDP, whoops, GDP changes the fastest, or very quickly, however you want to say it. So the question is, where are these inflection points on the graph? So let's go to the graph for a minute. And remember this, the graph, in the graph, the inflection points are where it changes concavity. So in this first section of the graph right in through here, you'll notice that the slope of the tangent line, so let me draw a few here. Okay, if you draw a tangent line at A, it'd be looking like that right there. So it's positive, but it's approaching zero at the very top, so it's decreasing. So the rate of change, which is given by the tangent line, is decreasing here because it's approaching zero, and then it becomes negative. Like at B, the slope of the tangent line looks like this. Okay, so when the rate of change is decreasing over an interval, you know the graph is concave down. So in this section here, it's concave down. Concave down, so it looks like a hill, okay? And then it changes, so let me switch colors here. It changes concavity at the inflection point right through here. So this next section of the graph represents a portion of the graph where it's concave up. So right here, this is IP number 1. Then right here, it's the second inflection point, so IP number 2. And this point here, it's going to be the third inflection point, so we'll call it IP3. All right, so where you see the inflection points, you see a change in concavity from up to down and down to up. So between the first and second inflection point, it's concave up. So this is concave up right here in this blue section right here, because the rate of change, okay, it's right here, it's a steep negative number, then it approaches zero, and then at F, it's positive. So it's increasing over that interval, and when the rate of change is increasing, you know the graph is concave up. That's one of the key concepts for concavity. And then at the second inflection point, it switches and it changes to concave down. So in these yellow regions, we're talking about where it's concave down as opposed to concave up. So let me just note that here. So here, concave down. Okay, and then as opposed to the blue area where it's concave up. Okay, and then we'll formalize this later, and we'll write that down specifically. But that's basically what's going on in the graph. Okay, so you got to identify those inflection points, because that's the fastest rate of change, and then it either speeds up or slows down after that. Okay, so now at point D, the GDP is increasing. Is the growth of the GDP speeding up or slowing down? So at D, right up here, okay, so what's going on? So let's zoom in here. So at D, let's draw the tangent line. So at D, okay, there we go. So it's increasing right there. But you're approaching the max up here at the very top, so the slope of the tangent line has got to get to zero. All right, so it's increasing, but it's slowing down. Okay, so what we can say, so at point D, all right, to the peak, all right, the GDP is slowing down because it reaches a max value. All right, so the slope of that tangent line has got to approach that horizontal line. So let's summarize that. All right, so at point D, all right, to the peak, all right, so at point B and then towards the peak, right there, the GDP is slowing down because the slope of the tangent line, all right, is approaching 0 at the very top. So it's got to be slowing down. The GDP, or the rate of change of GDP, let's actually write that. So the rate of change of the GDP is slowing down. All right, because it's reaching that max value at the very top where the slope is 0. So it's got to be slowing down. Number 6, when is the GDP fastest? How can you tell this from the graph? Okay, so as I was saying earlier, the GDP changes the fastest. Let me see, changes fast at the inflection points. Okay. So let's write that down. So that's the GDP changes the fastest at the inflection points, which we discussed earlier. So when is that happening on the graph? Okay, so if you go back up here, so the first inflection point is between B and C. So if you're at point B, between points B and C, it's going to change the fastest at the first inflection point, and then between F and D, all right, and then right before point E, you also have a point where it's going to be changing the fastest. So let me summarize that. So between, let me see, it's points B and C. Oops. All right, between B and C. Also between F and D. And also just before point E up there. Just before point E. Okay, look at the flexion points. So at point E is the slope of the curve negative or positive. So let's go back up to E, draw the tangent line, and then we'll see what it's all about. So I'm going to just draw it in. So remember, the tangent line intersects the curve at one point. All right, the slope's negative there, so it's negative slope. So which means that GDP is decreasing. So GDP is decreasing. All right, because the slope of the tangent line is negative. Because the slope of the tangent line is simply negative. Okay, it goes down to the lower right. Okay, so let's summarize that. Okay, so at point E, that's the slope of the curve negative or positive. Okay, so at E, all right, the slope is negative. Okay, which means that the GDP is decreasing. Okay. Now at point E, are the slopes increasing or decreasing? What does this tell you about how GDP is changing at this part of the business cycle? Okay, so let's go back up to the graph here. So let me see, we're dealing with point E. Okay, so let's zoom in here. Okay, so notice that I already drew the tangent line at E. So I want to draw a few more here. So you want to figure out what's going on with the GDP. So I want to pick another point on the curve, draw another tangent line here. Down here, draw another tangent line. So notice that they're negative, but it's flattening out, and you got to approach that relative minimum there at the trough where the slope is 0. And if all the slopes are approaching 0, that means that the rate of change is got to be increasing. Okay, because you're getting closer to the trough where the slope is 0. So the key on this is to understand the slope of the tangent line and what's going on. Okay, so we're going to say that Let's see, what is the question? Let's go back up here. Point E, are the slopes increasing or decreasing? Okay, so they're increasing, as I was saying. What does it tell you about the GDP? And or how it is changing at this point? So it's increasing. So at E, and so at point E, all the way towards the minimum there at the trough, okay, the slopes are increasing because they're approaching zero, which is at the bottom, where the slope of the tangent line at the trough, where the relative min is zero. So the slopes are increasing. What does that mean? That means the so the rate of change of the GDP, okay, is increasing over that interval. Okay. Describe what is happening at point F with as much detail as possible. Okay, so where's F on the graph? So F, let's zoom in here. So find F here, and notice F is right before the inflection point. So definitely there, the GDP is increasing, and it's coming close to the inflection point where the GDP is actually increasing the fastest. Okay, because it has the steepest slope there at the inflection point. So at point F, the GDP is increasing at an increasing rate because you're approaching the inflection point. Okay, so let's summarize that. So the no, excuse me. Let me start off and reference point F. So at point F here, okay, the GDP, because that's what we're talking about in this situation, GDP, gross domestic product, there is increasing because the slope of the tangent line is positive, so is increasing, okay, here we go, at an increasing rate. So it's increasing faster at an increasing rate. Okay, so notice the terminology right here, at an increasing rate, because it is approaching the inflection point. Okay, now remember, the inflection point is where it changes the fastest, and that's the key. Okay, so when I say inflection point here, that's the point where it changes the fastest. Okay, IP is where the GDP in this case, okay, or whatever we're talking about, changes the fastest. Very important concept. Okay, so you have to locate the inflection points, know where they are in the graph, because that tells you where the quantity is increasing the fastest or decreasing the fastest, depending on where you are in the curve. Okay, now having said that, let's formalize everything. So go ahead and take a moment and pause the video if you need to, or just go ahead and start taking some notes on this. These are the learning targets. Remember, LT, okay, is learning target. So I'm going to formalize what we did in the lesson there as you go ahead and take notes on this. Okay, so given a function which increases and decreases over time, first thing you need to know, LT number 1, learning target 1, is that positive slope, okay, in reference to the tangent line. That means the output is increasing, okay? So again, I'm referencing the tangent line here. And then if it has negative slope, the output is decreasing. Okay, so positive slope right here. Okay, it's increasing, negative slope. I'm just going to draw a tangent line in here. Okay, that's negative slope, so it's decreasing, and then positive slope. Okay, positive slope right there, it's got to be increasing. So learning target number 2. Well, I've talked about this extensively, but let's formalize it. So rate of change, okay, rate of change. If the rate of change over an interval is increasing, that means the slopes are increasing. That's what it means. So rate of change is slope. You got to connect those two concepts in your mind. So rate of change and slope, synonymous there. If the rate of change is increasing over an interval, the graph is concave up, so it looks kind of like a valley. If the rate of change, ROC is rate of change, is decreasing over an interval, okay, over an interval, over an interval, which you'll be able to find that pretty easily. Okay, so I'm always talking about over a certain interval here. I should have said that in the beginning. Okay, so the rate of change, if the rate of change is decreasing over an interval, all right, so it starts from positive and maybe goes to negative. It's decreasing. The graph has got to be concave down, so it kind of looks like a hill. Learning target number 3, you need to find the inflection points in the graph. They're important points, and the points of inflection is where the concavity changes. Okay, it also has a steepest slope at that point. Also, it is where it changes the fastest. Okay, so it's the steepest slope, and it's also where the function values where it changes the fastest. Okay, steepest slope changes the fastest. So you got to connect those things in your mind. So it could be increases the fastest if it is on an upward trend, or it could be going down. All right, and if the slope's negative at the inflection point, that's where it decreases the fastest. So those points are really, really important to find in any problem given the context. Okay, because it is it represents where the function, whatever the function represents, changes the fastest, i.e. it has the steepest slope. Okay, and now it's your turn, okay? And guess what? Go ahead and give this a shot, and you can check that online. I'll post the solutions or send them out to you guys. Okay, now remember, this is a video, right? And if you need to rewind and listen to it again to search for understanding, go ahead and do that. Okay, what copying doesn't really help you anything, and I always tell you everybody this in all my videos here at the end, because copying never helps anybody. So go slow, go at your own pace, listen to it once or twice until the light bulb goes on, until you actually understand it and can apply it. And if you do understand it, then you should be able to do the check for understanding on your own. If you can't, and you're making mistakes, or you just flat out can't even answer a question, that means you need to go back to the lesson here, all right, and listen to it again. So be smart, be wise, use the videos properly, and I'll see you in my next lesson, okay? This is Aynesworth. Have a good one.